11. Write cell schematics for the following cell reactions using platinum as an inert electrode as needed. Okay, easy enough. So we have magnesium solid plus nickel 2 plus aqueous yields Mg2 plus aqueous plus nickel solid. And from here, we have to write a cell schematic. Now, whenever we're talking about cell schematics, there is a specific way that we have to write these schematics. And basically what a schematic is we're just basically writing out, for lack of a better term, it's kind of like a drawing. It's another way of writing this balance equation. The general form for a schematic looks like this. So I'll just put it over here, and then we'll do the answer on this side. So there's two parts for a schematic. You have the blue section here, and then the red section. These represent the half reactions of the balanced equation that they give you. So just look at the partners, right? That's the only thing we basically need to know for now. We need to know who's the blue and who's the red. So seems like magnesium, right? Magnesium being a solid, its partner is this one, right? Because they're both magnesiums. One has no charge and the other one has a 2 plus charge. And then you have the nickel, right? That's aqueous. That's the 2 plus. This is going to the nickel solid. So now I'm just going to box these off. This goes with this. And this goes with this. Okay, cool. But now, which one goes on the left side of the schematic and which one goes on the right side? Well, it all depends on who is the anode, aka who is undergoing oxidation, and who is the cathode, aka who's going under reduction, right? So in this case, we're talking about a transfer of electrons. That's what these cell schematics are all basically talking about. Which component goes under oxidation and which one undergoes reduction. Now remember, Leo the lion says grr. Leo, L-E-O, loss of electrons is oxidation. If you are becoming more positive, that means that you're losing electrons, and that's oxidation. On the flip side, gain of electrons is reduction. That's becoming more negative or becoming less positive. Whichever one you want to think of, that's fine with me. So let's just find out these charges. Let's focus in on magnesium. Now, in the beginning, it just said magnesium was a solid. There was no charge in the upper right-hand corner. What's that charge, guys? Yeah, it's a 0. So in essence, magnesium went from a 0 to a 2 plus, or plus 2. Now you say to yourself, okay, going from a 0 to a plus 2, did I become more positive or did I become more negative? Yeah, I became more positive. And if it's becoming more positive, that is oxidation. And this would essentially be the anode. Now you could always just double check yourself, right? Because you can't have 2 anodes and 2 cathodes. So that means that the nickel has to be the cathode. Let's just make sure. So nickel went from a plus 2. Maybe I'll put it over here. Went from a plus 2 all the way to, well, I didn't see a charge in the upper right-hand corner. That's a 0. So it went from plus 2 to a 0. Becoming more positive or becoming more negative? Yeah, you're dropping a number. So this is clearly reduction. You're becoming more negative. And that's the cathode. Now all you have to do is just write it in this little schematic. So let's just look at the oxidation one. This is the reactant, and this is the product of your anode. Remember, which was the magnesium. So the start was Mg solid. So that's who I'm going to start with. Mg solid. This little bracket just means that now I'm going to the product side. So Mg solid went to Mg2 plus. So I'm just going to write that, Mg2 plus aqueous. Now I'm transferring over. I need that double bracket. Now I go to the red side. Same thing as before. This is the start of the red, so that's the reactant, and this is the end. So the start was the nickel 2 plus. 2 plus, and that's aqueous. I need the bracket. And then I'm going to say the other one, nickel solid. And this is the final answer. This is your cell schematic. How easy is that? Now, I just want to point out here, they did say that, we have to use platinum as needed. Now, we only use platinum when we see that either both oxidation guys or both reduction ones are aqueous. But in this case, since we have a solid, we don't need platinum. And for my reduction side, my cathode, we have a solid, so we do not need platinum. But for example, if I did, just change this to aqueous and we had 2 aqueous species on the cathode side, then we would use platinum. But in this case, we don't need it. So, final answer, box this off. How easy was that? And I don't like this yellow, so I know. But it's gotta look nice, There we go, much better. That is the final answer. I really hope this helped. Thank you for viewing the video, and let us know in the comments. Love talking to you guys. Like the video, tell your friends and your classmates about this channel. We're almost at 30,000 subscribers at the moment, which is absolutely incredible. It's all because of you guys. So thank you for supporting us. And yeah, talk to you soon. Bye-bye.